Live?
Yeah, let's start. Hi
Okay.
everywhere. Hi everyone. It's a SerpApi show. It's a first episode. We will talk about machine learning for web scraping with Emirhan. Emirhan works at SerpApi. And could you please introduce yourself?
Yeah, I'm a software engineer at SerpApi. Uh, I am a machine learning enthusiast. I'm not a data scientist, not a machine learning engineer or anything like that, but just an enthusiast. And I happen to work on some little projects containing about machine learning for web scraping, and we will be talking about that today.
Cool. So you can you tell me why have you started trying applying machine learning for web scraping for uh, what what kind of goals have you achieved and what do you want to do next and something like that.
So, first of all, I think we need to get into where the machine learning should be applied in today's standards, which is machine learning is successful at many things, but if you actually separate the areas that it is successful versus it isn't, it is obvious that machine learning is doing where the traditional methods are failing. Bank fraud, for example, is a great failure on the side of the banks. And it cannot be contained with traditional methods because you literally cannot observe every transaction and see if it's fraud manually. It's impossible. So any kind of increase or in the bank fraud case, decrease in bank fraud is extremely useful for banks. So they are applying machine learning in that sense. In our case, we had a really problematic parser we had to maintain almost every 2 weeks, and it had enormous amounts of conditions because it was so dynamic, and there was nowhere for us to link the data with some kind of hook so that we can understand, oh, okay, this is this data and this is that data. It was extremely dynamic, even for one language, uh, and it was hard for us to contain. The project I have worked on, which isn't implemented yet, it is all still in reviews, but the project I implemented, before that, it was giving every time we fix, after 1 week, it was giving 10% of the results correct, which was problematic for us. Like it was giving phones in some fields that it shouldn't. It was giving address in phones. Everything was everywhere.
Mm-hmm.
So, and there was no way to contain it with the traditional methods. So what I did is that I have used natural language processing, basic natural language processing, to apply it into uh, that specific parser, and I have created an ensemble learning mechanism by combining it with traditional methods like regex, which
Mm-hmm.
is really fast. It's really good to use regex in the data flow where it's going into the model, where it's going out of the model. You can catch too many, you can decrease too many errors with that. Uh, yeah, that was the intention that I
Mm-hmm.
was going for.
And what is the current state of this project?
Well, it's in reviews. I have developed some kind of testing, which is testing the probability of it being right. Like it has some data sets that it should follow and see how much of the results are true. And I think I have written another one for live results also. I'm not sure that I can't remember. here's another thing, like it's really hard to contain machine learning models with unit tests as we do in traditional software engineering. Like there are places that we need to be 100% sure that we are doing the right thing, and we need to test it thoroughly. In case of where the machine learning is used, it's not the case. Like we have to have a probabilistic model where we are testing if the model is successful 90% of the time or successful 95% of the time within the trained data set and things like that.
Makes sense. And I have read, like you have published some articles about testing machine learning models. Can you talk about that?
Yes, so it wasn't quite about, I actually made a distinction there to, so testing machine learning might mean many things, one of which is minimum functionality test, which is seeing if the model is going to be useful for the specific task, which is by creating little models and getting the accuracy values from them, you can say, okay, if we scale this model up, it is going to work for us for a big data set. This is one kind of testing. And there is another kind of testing, which is testing to see if the results are giving the right answers in scale, which is what I did with the current project. But there is also another kind of test, which is just like a unit test, resembles a minimum functionality test, but it is about seeing if the model is being auto-trained by unit tests. Like you give parameters and then see if these parameters are the valid parameters for this specific model, which is what I have done in automatic images classifier generator. I know it has a long name.
Uh-huh.
And it was testing, it was just like testing parameters in traditional software engineering and nothing actually complicated if you think about that. So the article that I wrote was about the third kind, which is to test the endpoints to see if it's triggering a training process. Yeah, that's it.
Mm-hmm. Makes sense. And uh, what do you want to like do more with that? Like what do you plan to do next in your articles or when?
In the short run, there is a good answer to it, which is what our CEO Julian has dreamed about, which is to create a scalable general classifier using subdata. But the current project that I'm working on, which is automatic images classifier generator, it is good for making tools. So it could be used as a tool, but it is also good for using tools. And its main purpose is to create tools, because you can use customizable dictionaries to create databases on the fly, which are specified, because SERP data can be targeted. Like you can use the SERP data to get exactly what you want in a data set and in exact sizes, in exact formats and things like that. So it really reduces the weight that is hindering the training process. So using SERP data to create scalable models is actually a really good idea. And then comes the scalability part. This is where I have used customizable dictionaries uh, to test models to see if, for example, if a learning rate what a learning rate is it learning rate? Yeah, you know, learning rate should be for a specific optimizer, for example, and that these kinds of things could be utilized with the automatic images classifier generator. You can find it on our GitHub page, by the way, GitHub/SerpApi. And from there, we want to minimize it, which is currently what we are heading towards with the current articles. Uh, what we are heading is a terminal tool, which could create classifiers on the fly using SERP data. Can you hear me?
Yes, yes, I can hear you.
I just see myself. That's fine. So this is the aim of these articles, to create a command line tool that is so easy to use. Like you can write cat, dog, and then give it an image and see whatever this is classified as. This is the aim of the articles now. But on the long run, I have no idea what to do with these knowledge, to be honest with you.
And what do you mean? Like you have mentioned scalable. What do you mean
Yes.
here by scalable?
By scalability, I mean there shouldn't be a major difference between classifying, a, doing a binary classification and a multiple classification. For example, if it's easier to say if something is a dog or a cat, but it's harder to say if it's a cat or a dog or a fox, for example. And the reason is simple. If you think about it, there are characteristics of these three animals that are too similar for a machine learning model to comprehend it. I'm using CNNs, for example, like it's going through the details. For example, it has an ear that has this shape, and it's learning these. I know it sounds like impossible, but it's actually a really simple algebraic operation. It's not that taking the vectors and then calculating the numbers. And so by scalability, I mean this. I am currently working on an ensemble model with, so there are too many terminology that has popped up in the last 10 years or so. So it's really hard for me to classify it as something, but I'm going to guess and say it's hard vaulting because it's using multiple CNN models in parallel and then classifying it as the majority vote of these classifiers. So it is an ensemble model that I know for sure, but I don't know if it's hard voting or it should be classified as something else. But important thing is that we need to make it work.
So if some like I'm trying to imagine like that terminal tool. So someone like how would it work? Like
So if you want something that you don't use too much, you don't need a tool like this. You can just use SERP APIs, Google Reverse Image API, for example, and then get your result from the most common keys. And that easy. Actually, I can make a blog post about it. But if you need something that cannot be recognized that easily, like for example, the blueberries and blackberries are really hard to classify, even for human beings. And if you need it on an industrial scale, you definitely don't want to pay big amounts of money to some corporation, and you want to create an in-house solution. Like if it's feasible to create an in-house solution, and from there you can, for example, whatever you have in the production line in the factory, for example, you can get their images, and then you not get their images, like get their label names, and then get the SERP data for it, train a model. It might not be quick if it's too big, but in the end, the after the training process, it'll be much more faster for you to use in-house solution to classify objects in real time. That's one of the use cases that I can think of.
Mhm. But like speaking of image classification, uh, will it be like will like the if you like compare that machine learning model like own and like reverse image API from Google, Yandex, or whatever, what is the reason for using like for creating or what is the reason for using the tool instead of
Okay, so
using
I can give you a really direct answer on that. Many of the developing countries, for example, don't have the financial gains to create real good optical sensors, and they cannot afford many of the things. So it's feasible for them to use human labor to classify items while they're on
Mhm.
the production line. So it is like it this these kinds of approaches in machine learning could cut down the human labor cost and give some profit to the people. I don't know if it's an evil thing to say, but I mean that's one of the use cases.
Interesting. Interesting. And you have mentioned SERP data several times, and by SERP data, do you mean like results from images?
I Yes, I am specifically referring to results from images, but from what I can see, many of our customers are using SERP data in text to uh, use it for industrial purposes, whether
But
it be
your
SEO or something else, something more specific.
but your articles are targeting images only.
So my first articles were on text classification,
Mhm.
but it was for our own in-house solution for that specific parser. But then I had a failed experiment with general testing purposes with JSON. Now it is about images, right? Yeah, the last series are about images.
And what failures have you like? What failures were with general testing?
So the main failure for me was to think that it could be easier to write a Ruby, uh, write Ruby methods for it. So Ruby is a good language. It's an easy language, uh, and I think it's the easiest language. Uh, and here's the problem though: Rails don't have that much gems for machine learning. It's mostly taken from C++, and they're direct translations, and it's not feasible to create something from scratch. I thought about doing it for a specific case with a customizable canon. It's not actually a total failure. I mean, I've done some things, but I've made a mistake where I should have calculated the bias that comes from a majority data set versus a minority data set binary classification, which was my mistake. And then I just quit and then went on to the next topic because I
Mhm.
didn't want to do everything from scratch. I can get back to it in the future though, for general testing purposes.
How have you how had you gathered data for testing that testing?
From our own endpoints. So the general aim was to create a general. So the idea about that was something more subtle. So we are testing right now. Our tests are open sourced. You can see them at GitHub SerpApi, and let me rephrase, some of our tests are open source. So we test if something is a string. We sometimes test if something has this string, substring within it. But usually, the way we do the latter test is by having an error in the first place. Like if we have some residue of HTML within a string, that is the description, and it shouldn't have it. It should be served to the customer that way. When you look for things like that, you most of the times you don't even realize it because the ecosystem is big and we do maintaining all the time. You get the response from the customer, but there is actually a way to create a classifier. Not even a class. I don't know if it should be considered a classifier, but there is a way you can get it with machine learning, like to check if it has high probability of containing HTML elements that are residue in a key that shouldn't have HTML residues. So that was the initial aim of it. I'm sorry, what was your question? I forgot about it.
I have asked about how had you gathered the data for testing,
Yes,
like.
for the data, I used our own endpoints and I used our own test files that we use.
So in these cases, you were testing basically the response schema.
Yes, yes. Mhm.
And I was wondering whether you like manually gathered data from endpoints or have you streamed it from production or staging and
I actually used the. We have too many tests to begin with. We
mhm.
are a test-driven company, so we have a lot of tests that are already within the stack, which could be utilized to do machine learning projects. But for example, for the parser project that I mentioned, which was the structuring the unstructured data, I had to use our endpoints. Like for example, the specific parser was Google Local Pack, which is the kind of ads you see on top of Google about places, and it has numbers on it and it has addresses on it. That was the specific case. There is a way to get quite similar data from Google local results. So I have used, for example, Google local results uh, to like our engine to gather data to create a machine learning model for Google local pack, because local pack is just uh, inline local images, sorry, inline local results within Google's results when you Google something like the main Google page. So yes, I have used, but I didn't even use technically I have used production. I
Mhm.
used the development environment, but I have used our own service to create a data set for it as well. So it's a
Makes sense.
360 approach.
And uh, for these tests, what tools have you used and why? And maybe we can like, what do you think if we will if you will share your screen and we will go through some of like of articles we are talking about and you can explain what like more in detail. Like, what do you think?
Yeah, for sure, for sure. I mean, if the users aren't going to be bored, we can do that. Let me see. How do I share my screen on this one? It seems
There
complicated.
is there is a button.
Uh,
uh, Problems in the first episode.
yes,
I
I found it. I found it. Um, Let me close my camera though, because can you
cool.
see my
Yes,
screen?
I
Yes.
will. Uh-huh.
Can you see it?
Right. Yes, I can see recursion. Yep.
Yes, let's see. So we need to go back. So we can actually start from the end result of that parser project.
Let's try.
This is not even the end result. I actually improved this one. So I gave a pointing system for the parser
What do you mean
versus
by pointing system?
it's a pointing system that gives, like, if it gives correct parsing, it gets 3 points. To compare the traditional parser versus the machine learning hybrid parser. If it gives incorrect parsing, it gets -2 points. If it gives, if the correctly parsed value appears at another key, which is confusing, but it still did its job, it means +1.
Mm-hmm.
If more than one element appear at unwanted key, like there are separations that you need to do, then it's also -2. If a text within the part of the HTML is not scraped uh, in any of the keys, it'll be -1. So if it's skipping something, it's also -1. I think this is a fair system. And if you look at the keys that I have limited the keys that should be done with machine learning. So if you look at the rating, ours is not true.
Mm-hmm.
This is the traditional parser. Yes, I'm not surprised. So if you look at the rating, it is true, but everything else is within the keys that are being configured. But if you look at the
Mm-hmm.
traditional parser, it gets everything. Sorry, if you look at the machine learning hybrid parser, it gets everything right, which is really crucial to get our information. Uh, so if you look at the fields in this one, which is a search for dentist, it gives 4.8 score. That is correct, but everything else is incorrect. And in this one, everything is correct. Everything is where it's supposed to be. It's just missing some things, which is, by the way, if it's missing something, I don't give it -2. The reason is simple because it's less confusing for the user to not get a wrong key. So it's actually doing something half right, but it's still wrong. So in I can go through examples, but some of these have really bad scores for the traditional parser. And one thing I noticed is that some of the things that are crucial for the users, for example, the phone number is a really, oh, I shouldn't have shown the phone number of places there. I'm just skipping them.
Mm-hmm.
Phone number, address, or the open hours is another trending one. So these kinds of data are more important, and luckily they are getting more easily. I don't know why. I haven't made anything special for it.
Mm-hmm.
One other thing I have realized is that if you have more keys, you have more chance that you're going to have a successful passing with machine learning model. But if you have less keys, it's there might be some errors, which is kind of good because we want the big data to be scraped more easily. In terms of efficiency, I need to do another benchmarking, but this one was showing the benchmarking. Yes, 1.68 times slower, which is acceptable because it's just only one part of the body, and it is giving So it is giving wrong results anyway. So 1.68 slower passing time is not a big deal. But it is slower to do it with machine learning
And
because
and in
yes,
absolute numbers, how much it is, like seconds, milliseconds?
milliseconds, yeah, not
Mm-hmm.
nothing noticeable. I don't remember the exact number, but when we discussed it with our CEO Julian,
Mm-hmm.
he he was satisfied with the number. I don't remember the exact number though. It is in milliseconds though, because traditional parser doesn't take that much time to.
Mm-hmm.
We usually give our return rate is really good. Like return time is really good. I can show it in here, I think, from the API status. Ah, yeah. So response time is for ludicrous speed, 3 seconds in average. Ah, it's actually gone down right now. So it's 2.04 seconds, and for the ludicrous speed, it is 1.1 seconds. So it's not something that will disrupt the production for anyone.
Mm-hmm.
So I have taken a different, I have taken different paths for it, and then found a way to improve it. For the investigation of machine learning tests, it failed. So I don't actually need to show that. So this one, which is the automatic images classifier generator, it is so it is. I think I can show on this one. Yes, so it is using FastAPI, which is a framework on Python, and SerpAPI, and a Couchbase server, which is for storing images. But in the command line tool, I will separate them from these requirements so that we have
Mm-hmm.
a good way to use it on every platform without any problem.
Mm-hmm.
So to train a model, for example, you can use for multiple queries. This is more interesting for in terms of SERP. You can use American Foxhound, German Shepherd, and Caucasian Shepherd, and get the desired chip's name. For example, what is a desired what is a desired chip's name? It comes from here. So uh, you can actually pick something to be exactly dog, and not the American Shepherd. Exactly to be, you can say puppy, for example. Yeah, there is dog. Uh, so this is going to give you only the results for dog. Like it's not going to give you a shepherd that is American.
Uh-huh.
It's going to be only dogs and maybe some human beings in the background, but the main team will always be dogs. And this is actually not a problem because this is a minimal noise still. Uh, and from there, you can create a classifier that classifies between American dog species, for example. So this is really useful for creating big data sets on the fly
Mm-hmm.
with SWOT data, and which is really good thing for me because I was looking for databases before. Now I can create them on the fly, which is really good. For training a model, I have used an approach to wrap PyTorch and Pillow library of Python, for example. And the Pillow library is just a support library for PyTorch transforms there. So transforms library is responsible for shaping the data before you put it into training, and it is relatively easy to create a customizable dictionary and then use it to train. And I have applied, although my computer is not fast enough, you can do a sync training with it, which is to do them without. Actually, you can explain it a sync process better than me, I think.
Mm-hmm. Do you want me to explain?
Oh yeah, yeah. Hmm.
Uh-huh. Do you mean async searches of
Yes,
SerpApi?
sync versus the sync, so that I don't make any mistake in my
Okay.
explanation.
So there is uh, there is an async equals to parameter that can be used for SerpApi search endpoint, and this way SerpApi will not immediately process the request, but return only search metadata, and it will be available for polling the response. And by search metadata, I mean search ID, status, and JSON endpoint to poll the data. Usually, the response of the async search will be available within like 5 seconds, maybe 10 seconds, depends on the difficulty of search keywords. For example, uh, when we send requests to Google, like actually I haven't expected the question, so I oh, when we send some requests to Google that contain multiple search operators like in URL, in text, or and or operators for Google, for example. Google responds a bit slower. And if you want to send, for example, 10,000 requests per second without async equals true search, uh, it takes some effort to configure the server that is sending, like the client. But if we send async requests, it's a simple queue. You send the request, get the response with the endpoint to poll, and then just try to get the results each second or something like that. We don't have webhooks right now or WebSocket API or anything like that. So right now it should be only polled, if it's a word. Uh, so yeah, something like that.
So in the same way, not exactly the same way, but in the same way, you can do training processes uh, by polling them in the automatic images classifier generator too, you, which is really useful for parallel training. Every training is saved in an object in the database, an
Mm-hmm.
attempt object, training attempt object, and you can store the training losses within that object, and you can use the like you can store the parameters that you have used for this training attempt, and you can also test it and then use the test to save the testing results within that same object. This way you can get a different, like the metadata necessary to maximize different approaches.
Mm-hmm.
Um, let's see. I have also talked about its advantage in ensemble training. I can get into it really quick. So, because you have specialized data and a way to test what is the best way to do it, to do a binary classification in this case with CNN. You have so for example, if one of the classifiers, binary classifiers, is breaking, you can update its database and then train it again to do specific fixes to that part of the model,
Mm.
which is really useful to control the failures and minimize them. This is, for example, this one is using images that are only 500 to 500, which is another way to control noise because usually you
Mhm.
have when you do kernel processing, it's it might be hard to calculate it, and you may need some sophisticated, not really sophisticated, but
Mhm.
on top of all the complexity, it adds more complexity. So you might need some kind of formula to reduce the noise from different sized images. And for that, to minimize that, you can use only images that are 500 to 500, for example, and then reduce them down to whichever pixel you want. The important thing is that you choose the shape of the images you want to train your classifier on.
Uh,
Uh, Things of this nature. So let's see. Uh, So, for example, in this short run, it actually worked. It's it's doing a comparison between is it American high. I gave it a picture, an example picture, and it was checking if it's an American hairless terrier or an Alaskan Malamute, and checking if hairless terrier or an Eskimo dog, and Alaskan Malamute versus an Eskimo dog. And the prediction came out to be Alaskan Malamute because everywhere there was an Alaskan Malamute, uh, the prediction showed Alaskan Malamute, and two out of three predictions were Alaskan Malamute. So this is obviously going to give a wrong result. But because you have these two, you always have the majority vote for the right prediction. Would it work in the long run? No, because I need to optimize the binary classifiers themselves too to say that it will work for majority of the predictions that you will give an example of. Yeah, that's it.
Cool. Do you want to wrap up for today, or we can make a break and continue? But I would like to wrap up for today and
Yeah.
pick some of your articles for the next episode and go through it, or maybe even try some live coding. But if you have some uh, conclusion for what you have told right now, please go.
I don't really have a conclusion, but I have a message. Don't believe on the power of machine learning that much. It's a really specialized tool, and it's a traditional method is always preferable in today's standards. So don't fall for the hype. I would say that.
And what do you mean by traditional methods?
Like for example, in our passes, I wouldn't exchange all of our passes with machine learning passes because they are easy to maintain for once, and they are. It's easy to find an engineer who can work on a traditional parser.
Makes sense. Um, okay, so then let's wrap up.
Hmm. Thank you so
Uh,
much.
Thank you too, Emirhan. So it was a first episode of the SerpApi show. The topic was machine learning for web scraping with Emirhan, and via SerpApi we scrape data from Google, Yahoo, Yandex, Bing, Baidu, Walmart, and other search engines, and provide an API for that. And in the next episodes, we will probably talk with Emirhan more about his machine learning researches and challenges for parsing. And see you next time.
Yeah, see you.